Hey everybody, welcome to Math with ACE. We are going to be focusing on statistics today, specifically calculating using technology normal probabilities. We're going to be using our typical 1, 2, and 3 standard deviation values of 68%, 95%, 99.7. That comes from the empirical rule, but we are actually going to use Stapplet rather than a Texas Instruments calculator or Excel to calculate these values or the empirical rule. I could label 50 and use the standard deviation to give me, I would assume, from 56 to 40 something, but this is actually going to be 100% accurate, not an approximation, as we're using technology. So we go to stapplet.com and we select normal distribution, and we need to tell it the mean and the standard deviation. And I'm going to plot the distribution so I can see I actually am prompted with the empirical rule values of the standard deviation of 6 to the right 3 times and to the left 3 times. So I want to know about 68% of the x values lies within what 2 values. So I'm trying to find not necessarily the area, I'm trying to find the values. And so instead of calculating the area under the curve, I'm going to switch to calculate a value corresponding to an area. So then what I'm going to do is I want a central area of 0.68. I can't use 68% because I need to enter decimals. If I was to enter 68, I would get an error message because the area has to be between 0 and 1. That means I'm turning my percent into a decimal. And then I'm going to calculate. My region is shaded, so I know I'm dealing with the correct region. And the 2 values look like it's 44 and 56, but if you see down below, the range is actually 44.033 to 55.967. And then the nice thing about Stapplet is it actually calculates the z-scores for us. So it went through and said 44.033 minus 50 divided by 6. Here's this z-score. So even though the empirical rule tells us 1 standard deviation, 68% is actually just a little shy of 1 standard deviation. What about 95%? So again, as a decimal, I enter 95, and I am given 38.24 to 61.76. And again, I am not actually at 2 standard deviations. I am at 1.96. To the right and to the left, okay? 99.7, I enter 0.997, calculate the values, and I'm given a range of 32.194 to 67.806. And it's important to note that these values do need to be increasing to the right and decreasing to the left because you're getting wider and wider and wider. All 68 should fall within all 95, and all 95 should fall within all 99.7. Okay, well, what if I had a mean of 172.36 and a standard deviation of 6.34? The graph updates for me, and then I do the same thing. 0.68 gives me about 166 to 178. Now, if I was to round, I would be within what's shown on the chart, but I want to be exact. I want to give the information that is being requested. 95, again, just shy of 1 and 2 standard deviations. And then 99.7, I'm entering 9.7, and I get 153 to 191. Pretty straightforward when you're using Stapplet. You could calculate their z-scores if you wanted to, and then use the normal distribution with a mean of 0 and a standard deviation of 1, or you can just go straight for it. So I really think this is a great application, but it is also critical that you know what this is representing when you're doing this. So essentially, 68% fall within 166.055 centimeters and 178.665 centimeters for mean heights of 15 to 18-year-olds in Chile. Okay, thanks for watching.